And here we are combining like terms, okay? I'm going to try this, make this a little bit exciting, a little bit colorful. Goodness gracious, it's just black and white. Blah. Okay, here we go. Combining like terms, okay? So you've already written all of this down, okay? Or you should have by now. And I want you to look at this example when we talk about like terms, you guys. Like terms, okay, in algebra, if I were to put a plus x squared here, okay, write that down. Do it now, okay? You're writing it as I'm writing it on the board, okay? Like terms, you guys, have the same variable raised to the same power, okay? So these are like terms, so therefore I could combine them, and we always do what's in front of the term, right? That's addition. So we would do 3, we would bring over our x squared, okay? And 3 plus 1, even though it's not there, you know there's a what there? A 1, okay? So 3 plus 1 is 4, and our final answer would be 4x squared, okay? Yes, I'm writing on the freeze, whatever, go with it. Okay, but having that been said, okay, we said plus x squared, okay? What if, okay, I changed this to y squared? Are those like terms now? No, okay. No, they're not, okay, because they're different variables, right? What if I were to change it back to the variable x and do this? Are they like terms now? No, because they're not raised to the same power, okay? So what do we need to do? In order for them to be like terms, they have to have the same variable raised to the same exponent. I want you to think of it this way. If they don't look exactly the same, okay? If they don't look like twins, identical twins, if they don't look exactly the same, they are not like terms, okay? So let's take a look at our examples together, and we're going to go through it together. Now, again, I told you there are going to be times where I do things that you may think is corny. I don't care. Go with it, okay? Do it anyway. So when you see like terms, I want you to get into the habit of what I call drawing the rainbow, okay? Here we have 8x squared plus 2x squared. They are like terms, so I'm going to draw the rainbow just to visually tell myself that these are like terms. So all we need to do is bring over the x squared, and 8 plus 2 is 10, and that's our final answer, okay? Easy as pie. Now let's look at our second example here. Again, we're going to look at the list. We have 5x minus 3 minus 3x plus 6y plus 4. We need to identify what are the like terms in this list. Well, I see 5x and negative 3x. Draw the rainbow. Do it now. Yes, I said it. Okay? And we have a negative 3 and a positive 4. Some students think that they are not like terms because there's no variable connected to that coefficient, okay? But numbers are like terms. Please, please, please put the star. Okay? Numbers are like terms. Now this 6y, nothing to combine it with, so it just stays there all by its lonesome, okay? Moving on. So now we're going to combine them. So a positive 5 and a negative 3, okay? Positive 5, subtract 3. You always do what it says in front of the second term, okay? It's a positive 5 and a negative 3 gives you 2x, right? Now, 6y is all by itself, so we're just going to put plus 6y. Okay? Now we combine the negative 3 and the positive 4 gives me a plus 1, and we're done. That's that example right there. Fabulous. So let's take a look here. This looks like, you got to really have attention to detail, right? We have a 12x squared y minus 8xy squared plus 11x squared y minus 4x cubed y squared minus 9xy squared. Okay. So do we see any like terms? I do. We have x squared y here, and we have x squared y here. They look exactly the same. Okay, so let's draw the rainbow. Yes. Do we have any other x, y squareds in the list? Yes, we do. X, y squared. So draw the rainbow that connects. And this is the only term left over. So there you have it. Listen, in the directions of the assignment and the unit exam and things that you're going to get, it's going to ask you to write the answer in standard form. So everyone, I'd like you to write standard form. Let me see. Where do I put it? Let's just put it under the star, standard form. Okay, put the bubble. Do it now. Write it as I write it, okay? Standard form means that you're going to write your answer with the highest exponent leading the list, the highest exponent first, okay? So when we look at this entire list, which term in the list has the highest exponent? X cubed, okay? So that's going to go first in our answer. So negative 4x cubed y squared. Now let's do our combining. Here we have 12x squared y plus 11x squared y, which gives us positive 23x squared y. Okay, and like we did in our putting terms in order from least to greatest, it might be helpful when you have this really long list of terms to cross it out as you go so you know what you already took care of, and then you can visually see the only two terms that are left over are here. Okay, so now we have a negative 8, and we're subtracting 9 more, so we're starting off with a negative, and we're subtracting more, which means we're going further into the negative. Yes, we are. Okay, that's going to be a negative 17x y squared. And here is your answer written in standard form. Shazam! Yes! And folks, that is combining like terms. What's the takeaway? They have to be the same variable, okay? Raised to the same exponent, and our answers need to be written in standard form. Fabulous.